Hello everyone. The subject of our poster is probability, and today we will talk about this topic, and I hope you like it. We will examine the subject of probability under two titles, and finally we will finish the topic by summarizing it with a rule. Let's start. Firstly, we will look at experimental probability. Okay. Let's choose a spinner to see when we rotate it, different colors will come out. I construct two of them. I will delete some of them. Okay. Also, I will create a table to see different colors that come up every time we rotate. I will close this. Okay. Let's do our first rotation with spinner. As you see, the red sector is selected. If we try this again, this time it is purple. I will repeat this process 10 times and we will see how many times they come up on the table. It takes some time, of course. Okay, I completed the translation 10 times. As you can see, the sum of the values on the table is equal to 10. If we interpret these values with the definition of experimental probability, 10 is the number of trials for us. So, how many times did red sector come out of 10 attempts? As you see, it is equal to 3. If we write like this, 3 is red numbers in here. As you see, we construct a fraction. Also, we can write as a percentage. If you want, we do this example on green sectors. Let's change the pencil color. Okay. We did 10 trials and we saw green 2 times. So we can write like this. Also, we know that it is equal to also 20%. Or we can write like this. All of them are correct for probability. But we cannot write like this or like this. These are false to write probability. We have to choose one of these options. Okay? Let's continue with theoretical probability. I will use Toy Theater to show this title. I will create 5 circles in here, like this. What is the probability of me choosing a red circle out of these 5 circles? I definitely have to choose a red circle because I don't have any other color circles like blue, like yellow, like purple, etc. Therefore, I can write this probability like 5/5. We know that this is total number of circle and this is number of red circles on poster. Okay, also we know that 5/5 is equal to 1. But if I turn one of the circles like this, a yellow circle appears. So, of course, our probability will change. So, what will be our probability? Let's try to write. There are 5 circles chosen from. But this time there are 4 red and 1 yellow circles. So, to find the probability of red circles, we can just choose red circles and write like this. As you can see, the probability we found now is smaller than the first one. Let's turn the red circle once more. Which one is? This one. Okay. This time we have 3 red and 2 yellow circles. So now our probability is equal to 3/5. As you can see, the probability of choosing a red circle decreases with each turn of the red circle. And we can comment that our probability approaches 0 as we turn it. Because if we translate it all like this, okay, as you can see, there are no red circles. And if we try to write the probability of red circles, there are still 5 circles, of course, but no red circle, which is 0. Also, we know that 0/5 is equal to also 0. As you can see, the first probability we found is 1 and the last probability we found is 0. And also other probabilities we found were always between 0 and 1. We know that 4/5 or 3/5 is between the 0 and 1. From here, we can easily conclude that all probabilities are always in the closed range 0 and 1. We can also show this on the number line like this 0 and 1. Since there is no probability for event to occur, we can call 0 an impossible event. We can give an example for this. When a dice is thrown and 7 comes to the top surface, this is impossible event. Am I right? Yes. Also, we can call current events the situations where the probability of an event occurring is 1. This is current event. Also, we can give an example for this. The sunrise is a current event. We know that sun is rising all day. Okay? I will turn back Polypad and I will show last thing for this topic. And I choose a die from here and close this. Okay. Finally, let's consider the result of the sum of the probabilities of an event occurring and not occurring, like this. What are the numbers will appear on the top surface when the dice are thrown? We can construct a table to see them. I will close this one. Okay. Since the dice are cube-shaped, there are 6 number options that can come to the top surface, which are 1, 2, 3, 4, 5, and lastly 6. So, what is the probability of getting a 2 on the top surface? Since we only have 6 options and we only want the number 2 on the top surface, the probability we are looking for is equal to 1 over 6. Am I right? Yes. So, what is the probability of not getting 2? Okay. We have 6 options again, but this time there are 5 numbers that can come to the top surface, which are 1, 3, 4, 5, and 6. Okay. Since we don't want to 2, so the probability of not getting 2 is 5 over 6. If we add these probabilities, we get 6 over 6, which is equal to 1. We can also write this in here. This rule applies to all probabilities. We can use this rule always. Okay. I completed my topic. That's all I have to say about this topic. Thank you for listening to me. See you in other lessons. Goodbye.